Mhm. Mhm. Okay. And let's see what other things I could throw in here. Let's see if I can find another risk project solutions. See if I can find a nice little project for us to look at. Memory and pointers, winter exam due. You don't want to be, I won't want to be showing that to you guys. Thing, test code. No, a Super Bowl calculator. Screw it. I don't know how many people are jumping over here, but let me see. Oh, we got at least two. Nice. Range. Throw in your questions in the chat. I'll just throw up the chat here and then we can. Boom. I have nothing planned, by the way. So if you don't have any questions, I'm just going to be sitting here looking all pretty. Joking. That's how to program. Where's the class code? Class code. Sync. And let's.
Hello,
Oh,
can you hear me?
yeah. Yeah, I can hear you just fine, or actually a bit
Okay.
loud but that's
Oh,
me.
okay. Perfect. Thank you. How you been this morning?
A little busy, but that's perfectly fine. Nice. What's
Yeah.
going on, Tyler?
So just because the topic's fairly new, I have been practicing it. Are you able to possibly go over some of the file input and output?
File input and output. Sure. Let's do an example of that. Yeah, let's do a quick example of that. And yeah, that's a great point.
All
So
right. Perfect. Thank you.
let's see what I want to call this thing. It's just going to be sync file IO demo. Okay. Yeah, you should definitely make sure you're up to speed on that sort of thing. It's a mistiming more than anything. Assignment 8 was meant to be done, and then we were doing the exam afterwards with assignment 9, and then I've realized, oh, we're mistimed things. You could definitely do the exam with the material we've covered, but it does mean that I wasn't any kind of sort of time you would have to let it the file IO thing sync in gone. So let's do an example as you suggested. Okay. Right, and it's a C++ file. There we go. So I'm going to make I can't spell today. Wow. Hold on. Thing in there. I'm just actually going to include IOStream just because I know it's going to include everything but the kitchen sink in here. And I'm going to include my asserts. All right. Return 1. Okay. So I'm going to make a function called and I'm going to have a constant character array. Go. So I'm going to read in some random file, and that's all this thing is going to do. So let's. All right. So first things first, I need to open up the file, and I need some kind of file reader. So I'm just going to give it that name. I'm going to go back and do it later. Actually fill this in or open the file. I'm going to use a secure version of file open, but the other one's just fine. And it's supposed to take in this is going to be a little weird, but a pointer to a pointer, which is what this thing is saying. But if you're just following what we showed you in lectures and the lecture videos, it's just put an ampersand in front of the word, in front of my file. And this is a file star, whatever that means. It's actually a pointer to a file. It's a weird C thing. We can't get away from pointers, but pointers spook the hell out of everyone. So for the time being, at least, I'm opening a file. This is my file that I'm opening. This is a pointer. It works just the same as scanf. Notice scanf had that same ampersand in front of it. Okay, what else does this thing need? Let's have a look. So it's going to take in the file name, and then I have some kind of mode. And the mode is, so here's file name. All right, and it's some kind of mode. And if I'm reading in things, it's inside of an R. If I am writing out to a file, it's a W, but we're mostly focusing on the reading because the W is the scary one. You'll make a file and stuff things in it. If the file already exists, you wipe out the old file. Honest to God. Okay, so let's also make a resource file because why not? And new item. And I'm just going to make some kind of test web. Word. I just want to I want a text file. So there you go. Sure, it's going to be called test.txt. Good enough. And then how are you all today? Question. All right. First things first. I try and open the file. If this thing opens correctly, this will not be null. If it doesn't open correctly, it will be null. Null is 0. It is things just start up. It's pointing at nothing. We need some way of saying when things go off the rails, what does it look like? That's what that thing says. So if it doesn't open properly, it's going to be set to null. I'm now going to, if my file is not equal to null, I could also do a if this thing was opened properly because I can't type. There we go. This thing also returns a value if you want to do that. So it returns some kind of error message as well. If I can look into that. This is all going off of memory here, so I do it this way, just from memory. If it opens, then I can do something with it. If it doesn't open, I'm out of luck. We have fgetS, we have fscanf. We can use fscanf. Let's try that out. And I'm going to need some kind of, let's say, character array to store things into. Why not? So I'm going to have some kind of character array. Okay, and it's going to be size like 200. Well, let's make it 100. I know it's not going to be that big. I need some kind of really big character buffer just to see. Okay, f scanf works just like scanf. I can do the _s version of it, which is the safe version of it. I have p my file. I have some kind of, oh, and now I need to put, what am I pulling in here? I'm going to take in a string of text, and that is going to be going into, what's it going to go into? It's going to go into a text. I'm not sure if I'm going to be taking in the size of this array or not. I think I do afterwards. So let's put the 100 in there afterwards. We're going to find out. We don't do a lot of fscanf. So the other option we had was, and let's just, so I'll leave that in there. Let's put a comment for the other one. fgetS, this is the one you're going to be using for the assignment. Let's actually do it right. Let's put it in, then comment it out. fgetS, what does it return? It's going to take in my character buffer, a text, and the maximum count, 100. And that's the maximum I can put in there, and the file stream. So p my file. That's going to read in a line of text. Until it gets to the end of the line, it just keeps on putting crap in the buffer. It will put the entire line, white spaces, everything in there. So they are going to be very similar. One takes a full line. The other one takes in the next thing up until a white space, like scan was doing before, or scanf, I should say. Okay. Oh, I wanted to leave this one in, but take out this one, but they're the same. They're going to do similar things. Okay, I need to see if I get to the end of this line. So this thing here, one of the things weird things about this is it's actually going to return something. It will, I want to look into what this thing is going to return, but it should return the number of characters that were read in successfully. So what I want to do is while, and then put that in a while loop. So keep on, or I would have to store it and then check it afterwards. Is greater than 0. I'm going to keep on pulling in things. I'm also going to, the end of my function here, I'm going to say int num tokens, the number of words or number words. Let's say words instead. I'm going to initialize my variable. All right. So I'm going to read in that number of words. I'm going to figure out how many words I'm doing. Num words plus plus, as in every time I find a new word, I'm going to increase that count. Not really doing anything with this. I can look at what this, and let's do this. Print f word colon, and then I'll put in I want to see what this thing is going to look like. Put a new line. I'm just playing around with this. A text. All right. When I am done, so it's going to keep looping. It's going to keep looping until, and this is one of my things that I always have to worry about. Am I sure it's going to stop? I'm not sure it's actually going to stop. I want to be kind of on the careful side, so I could put some kind of like, in case of fire, break glass kind of thing. So maybe something like this. Num words. I'm going to assert. I want this thing to, I'd rather have the assertion go off and blow up than have an infinite loop personally. So this is me being paranoid that you didn't have to do this at all. If assert the number of words is less than 200. If I have 200 words in this file, crap is hitting the fan essentially. Okay, my search should be fine here. So why is that not? That should be fine. So why is my cert yelling at me here? Unless it's number of words. Problem with the asserts, the error goes out in the wrong place. Okay, so every single word I get, I'm going to output it. I'm expecting never to hit this scenario because I just, I want to make sure that this is somewhat safe. I'm going to increase the number of words. And when I'm finally done, I want to make sure I close this thing off. So F close and my file stream, P my file, when I'm done here. All right. And then I'm going to return num words. This is the number of words I've written. This is just for sort of fun. I also need to actually call this file. So file reader, here's my file name, text.txt. And if it doesn't work, I want to make sure it works, right? So maybe I want to do line by line, put a breakpoint in this thing. Let's see what happens. I could also do this. Let's put an else statement in here. That's the Java way of doing it. That's the C way of doing it. File would not be opened for some reason. Little bit at a time each time. Okay, then I would check my code. Hello, how are you all today? Great. It actually stopped. I didn't have an infinite loop. Good for me. I like it. Thank you. That's nice to see. I just pulled off each token one at a time. Notice some are on the same line, some are on different lines. Notice I also opened up the file and I had some kind of check to make sure that if things didn't open properly, I can yell at the person to say, hey, it's in the wrong place. Because if my file name is not text.test, let's say it's text2, 2, and then let's see what happens. It should say, no, that file doesn't exist for some reason. And now I know where I can track down my error. That is file IO. Do you want to see fget_s in action? But other than that, there's nothing crazy. I have a file. I call fopen, saying it's a read. I'm reading the file. This will set this value here, pmind file. And then afterwards, I can call fscanf, fget_s. The F stands for file. And then when I'm done, I press, I type close. I'm not hearing you, Tyler. I don't know why. Oh, you're muted.
Sorry, I was muted. Yeah,
Yeah.
no, that's great. That's perfect. Thank you.
All right. Other questions? That was pretty good for what, 10 minutes of work? There you go. Oh, sure. Or I can also try and maximize the size here. Where should we scroll that down? There it is. All right, next question. You want to look at strings? Do you want me to look at how long these things are? Maximum number of alphabetical characters or number of numbers that are in a string or whatever you want to do. Let's do that one, actually, if no one's giving me other questions. Can we check the amount of numbers in a string? Nice, great. And numbers in string. Okay, so I'm going to have some kind of character string. You'll notice I keep on using that A in front just to let myself know. It's purely for me, but it's also for you if you're reading. It's a naming convention. It's not actually doing anything to the code. It's just I have a terrible memory. You might as well. And I don't want to have to remember, is this thing a pointer? Is it this? Is it a? If I put an A in front, I know it's an array. I'm going to treat it like an array. If it's not an array, I shouldn't have called it with an A in front of it. All right. And that's the only reason I have it that way, that using that convention. You will not see that everywhere. Some people put S's at the end, but it's not as obvious for what's going on. All right. So here's what we have. I'm going to pretend, first of all, that this character, and I'm going to make it a constant character array. Simply, I wouldn't know. Let's keep it what it was. I'll show you a different thing to do. Okay. Uh, that's why I was asking about that. Very nice question, Anastasia. A constant character array means this thing is pointing at this thing. It's not going to move around. It's pointing at this array. So where the text is, you can technically, I think you could change the array, but you're not allowed to move where you're pointing to. You can't sort of point to something else. So that's what if you put the constant in the other place, so char constant pointer, it means, oh, sorry, let me think. I always invert them anyways. But effectively, it's this thing here. I can neither, so it's both in this case, I can either change the text itself, nor can I point it to something else. That's when we were talking about character strings. I'm not allowed, that's not just some array that I've made that I can modify. It's not allowed to change in any way. I can't point to something else, and I also can't change the text itself. And because of that constraint, normally that when you're not going to modify your array, you might say something like this: I am not allowed to modify this thing. But oftentimes we want a character array, a normal character array, or we maybe want to modify some things. So I normally think of char star because not most of my arrays are not constants, but that's why it gets a little bit convoluted because sometimes you're not allowed to change it. And so this is a file name. I'm definitely not going to change the file name here. This thing, I'm probably not going to change the file name here or to change anything about this either, but it's a character array. I want to be able to pass in a variable character array as well. So depends on how you want to view things. Let's put that back in because I have to explain it in words instead. But this means I know I'm not going to be modifying my array. Okay, so I want to find the number of characters, numbers in the string. So first of all, I want to get the length of the string. So find int text len is, now I could call this function over and over and over again, but that function takes some time. I've got to walk all the way to the end of my array, counting the number of characters. And if I do that every time through the loop, it adds up. So I'm just going to just strlen of a text. Great. I want to do unsigned int because text length is unsigned, I might as well make I unsigned, otherwise I get that little weird warning message. It doesn't matter for us, but I is less than text len, I plus plus. Notice the last position in my array, at position text len, I have a zero, that /0 thing, saying this is the end of my array. Notice with an array, with a character array, this is the one time I get to do this. Integer arrays, I can't do this. Double arrays, I can't do this. Text with a character array, with a string of text, a C string, I know I reach the end when I hit that special character. There's no special character I can put into an integer array to say I'm at the end of my array. What number are you going to plop in this array to say I'm at the end of my number system? They're infinitely sized. You'd have to throw away a perfectly good number to get that functionality. So the one place where you don't have to pass in the size of the array is with a character array, because you can use that 0 at the end to say when you're done. Okay. So I need to figure out if this thing is, if each character is, so we'll use an if statement, let's say. I need to see if the character is between 0 and 9, right? It's a numeric value. So if, so a text at position I is greater than or equal to, I also want to check out what the values are, but I think it's 0 to 9. That's the order in which we're doing things. I want to put a breakpoint in this in a bit, but I'll look at this in a second. All right. And a text at position I is less than or equal to 9. Why do I want to do that? Well, because I don't know the other ASCII numbers. I know for sure that they're in some kind of order. That's what we know about the ASCII number system. It goes A to Z lowercase, or A to Z uppercase first, 65 to whatever the number is. And it goes A to Z lowercase at the 90 something range. They're just numeric values. We need some way of converting binary, some bit zeros and ones in a computer, to text. So we have some kind of, we just formalized some mapping in the 1960s, seriously, about 64, where it's saying a C is going to be this, a D is going to be this, question mark is going to be this number. I can actually just test to see if this thing is equal to question mark. I could just do math. So if the character that I'm looking at is greater than or equal to the 0, the character 0, or greater than, less than or equal to the character 9, they're both that's not a number, that's a character. Let's be clear about this one. It's a character. Then if that's the case, I'm going to increase my character count. So, I'm going to need some kind of number here. So unsigned int nums. I want to initialize it first. Nums plus plus. All right. And then at the end of the day, I'm going to return nums. Okay. Let's try one of these things out. Numbers in string, and let's I every one. No, let's put a, let's try and do 3 3 0 3. If anyone knows what that is, let's put a this, and then There you go. If anyone knows what that means, you have too much time on your hands. Okay, really serious. It's old and it's lame, and I have friends that love this stuff, but not me. Okay, so does anyone know what that 1337 actually means? You can post that in a second, and then I'm going to just plop a breakpoint in here, and let's see what happens. Oh, convert argument constant to a character pointer. Oh, it's constant character pointer up here. Make sure it works. All right, let's find out. Okay, here goes nothing. I'm going to run it. I'm going to breakpoint at this thing. We're going to see what things are happening. Boom. Okay, what is text length? Is equal to 18. That's how many characters are in here. I, by default, have this 0 at the end. If I actually looked at my array, I would see it. In fact, I can, let's see, can I look at this directly? There we go, but it just has the text. It's not going to be, I might be able to look at the actual array. Watch, and no, I'm only going to see the first H. It's going to be 18 characters. When I get to the very end, it's going to be that /0 to say to stop. Okay, let's do this. So for each of these characters, I'm going to walk down my array and find out what this is. So the character I'm looking at right now, a text at position 0 should be equal to the letter H. And so I'm not going into that if statement. The next character, it should be a number. So let's see what the heck the value here is. 1. Okay. This value here is 48. This value here is 57. I can just hover over it to see it. So between 48 and 57 are my numbers, 0 to 9. So if I go one more step in here, I should go into my condition, increase the number. I miss it. I go in, increase my number. In fact, if I just run this thing, I want to, oh, I didn't store this afterwards. So let's stop here. Let's do this. Print f the number of numbers is /n. I'm just testing my code here, but that's not always the best way of testing my code. So let's have a look at that in a second. What do I expect to see here? 1, 2, 3, 4, 5. Oh, 6, 7, 8, 9. Should be 9. But /0 at the end, that's not the character 0. That's /0. It's a special thing. It's actually the numeric value 0. Doesn't count. Doesn't count in this count. Okay. So I'm expecting a 9 here. So that's my hypothesis. That's what I get in the. That's what I got in the end. Great. My code, I think, is working. Let's try something else. This is no. That's just bad text messages. Hello. Okay. No numbers whatsoever. I'm expecting a 0. So other things I could have done is something like this. I'll assert numbers in string 1, 2, 3. I expect that to be equal to 3, right? I can make up a whole bunch of test cases. The nice thing about an assert is it doesn't actually slow anything down. It gets removed when you do like a final build for customers or whatever the case is. It allows me to just test stuff. So I have 3 different tests, and I'm not checking to see what my output each time is. I don't have to monitor it. If this should always be true and I run my code and it breaks, I know something went horribly wrong. Okay, the test 2 is 0. Okay, 9. The other one didn't blow up. Good enough. So this is me parsing a string. This is me calling strlen. See if things are there. if you want, I can do, I don't know how much time we have, about 7 minutes left. We can also do a very, very quick look at comparing two strings. So do the worst function ever. So text equal, and it's going to be a constant char pointer, text one, constant char pointer, text, BXT2. All right, very original naming. Okay, all this thing is going to be doing is I'm going to see if these two strings are equal to each other. Because, okay, so what I want to say is, like, what I could do is this. If strcmp of text one, text two is equal to 0. So what I could do is this. Let's use a ternary expression because why not? 1, otherwise 0. So if they're equal to 0, so if they're exactly equal to each other, then I will return 1 or true. Oh, thank you. TX, thank you. That's why there's an error. Nice eye. If they're exactly equal to each other, that string comparison will return 0. Why? Because we want to know if text one comes first or text two comes first. That's why string comparison is so weird. It doesn't follow all the other patterns. It's if text one comes first, then we return -1. If text two comes first, then we return +1. It just how you can allows you to sort things easier versus are they equal to each other, right? So this is actually less utilitarian than the other one is. Return ret file. That's not the best way of doing it, but let's see it in action. And then I would expect that to be equal to those to be equal to each other, semicolon. And I would expect these to not be equal to each other. And so I'm going to test equal does not equal 1, something like that. We were talking about whether something is true or false. And so we could just say, rather than checking to z was it equal to 1, it's either 0 or not 0. If it's not 0, it's true. If it's 0, it's false. So we could do this instead of what I just wrote. They're exactly equal to each other. It's not. If it's 0, it becomes a 1. If it's a 1, it becomes a 0. So, and the assert should always be true. So let's see this in action. Hopefully it's going to work for us. And let's also break things one last thing, and then we'll, hey, nothing blew up. Good to go. And now we're going to break it. Boom. Why? Because I have a space in there. They're not identical anymore. So that's one of the challenges that you're going to have for the assignment is that, and I wasn't going to be picking on this. I made a note about that last night, I guess, but the spaces do matter. So you can call str as well, and that would also work. So what you might want to do is, so I could test if they're equal. I could say, how do we want to do this? str, text one, text two. Is text one a substring of text two? If it is, it tells you the pointer to where that thing is. And so I can see if that is equal to text two, where's the pointer of where that's located. or it could just say it's not equal to that, but this would be the exact same equivalent. If they're identical texts, the substring, they match up exactly. This is the substring of this one. It also should work the other way around as well. So we could say str text1 text2, xdr text2 text1. And as long as they're both equal to each other, okay, let's do that. So if it's null, it's equal to 0, so it's false. Otherwise, it's true. So therefore, it's I have a pointer that's not null, I have a pointer that's not null, meaning one's a substring of the other. If they're both substrings of each other, then they're equal to each other. One way of looking at this. If you wanted to try things that are a bit more fancy pants. Stop for debugging, and we have a breakpoint there. Okay. Oh, I'm missing a semicolon at the end. All right. Well, I'm going to stop at this point in time in a second, but hopefully we covered a lot of ground here. So, and it works just fine. And in case you don't believe me that this test is going to work, it should fail now. Because those are not equivalent to each other. They're not substrings of each other. In case I'm all for your especially for your assignments, do a little bit, test the crap out of this thing, make sure it works, then move on to the next part. If you just write code, say it compiled, it's working, then you don't know if it actually works. And so a little bit at a time, because the worst thing you can do is write a whole bunch of code and then try and figure out what the heck went wrong. You wrote that code 2 days ago and you have no idea why it's wrong, right? A little bit at a time prevents you from getting that kind of error, or at least reduces the chances. Okay, I have another meeting to jump to. It's actually my TA meeting for this class. So hopefully this was somewhat useful. This code is actually in our normal code repository. If you want to have a look, it should automatically be reflected up there. All right. So I'm going to stop my sharing now, but I do have to run off. So good luck in the exam, guys. I'm sure you're going to do fine. Just it takes just some practice. And if you've been doing the assignments, you should be fine. All right. Thank you very much. Have a great day, guys. Oh, I'm also going to be on Discord during the exam if you have any questions as they pop up. All right. Thanks.